This is chapter 9 in our book, Momentum. So this serves as an introduction. So Newton's third law, you might remember, is for every force of action there is an equal and opposite force of reaction. So momentum is a measure of an object's tendency to continue moving at the same speed in the same direction. Think about a train heading down the track, traveling, has a lot of mass, might have some speed, has a lot of momentum. It makes it hard to change its motion. This is a train from 1885 in Paris. Had a little bit too much momentum for this situation, and here's a reconstruction of it. Momentum, mathematically, is defined as the mass times the velocity of an object, and lowercase p is used for momentum. Yp, what I could find is this. From 1610, we had a pulse, and from the 14th century, the Latin pulsus, beating from to drive, push, or beat. In 1641, we have something with impulse, which we'll see the connection soon. So, momentum is mass times velocity, which is m times v. The units are kilograms, meters per second. So if we have a situation with a guy who has a mass of 80 kilograms, he runs at 5 meters per second, what's his momentum? 80 times 5, 400 kilograms meters per second. There are no other units for momentum. If you have a small mass and a large velocity, yet it's hard to stop. That's a lot of momentum. If you have a large mass and a small velocity, it's still hard to stop. If you have both, almost impossible. Impulse is for changes to momentum. It's a force applied over time, and we can write the formula impulse equals force times time. Impulse is sometimes used with a capital I, sometimes not, but it is equal to F times T. The units for impulse are Newton seconds. So F equals ma, which is the same as mass times the change in velocity over the change in time. Just a reminder, your change in velocity is your final velocity minus your initial. Change in time is just your final time minus your initial. Now, how do impulse and momentum equal each other? Let's look at some units. A Newton seconds is for impulse, kilogram meters per second is for momentum. So remember, a Newton is a kilogram meter per second squared from F equals ma. The seconds cancel out, and you have the same units as momentum. Unit analysis rocks, huh? So, impulse equals change in momentum. And Newton's second law was originally stated as this change in momentum over a time interval. Think about a huge cargo ship, how long it takes to slow it down. Lots of momentum. And in class, we will be doing an experiment that I call conservation of momentum. So your task at the beginning, well, actually the end of the lab, is to define conservation of momentum. So you may want to think about that before actually doing the lab.